And so it is. Welcome to ES2015. Welcome to the rock. All right, nothing up this sleeve, nothing up this sleeve. I make an index.js file. We've got default function params, rest and spread. Template literals. Destructuring. Let and const. For of bad arrows. Class keyword and promises. Cool. I would call all of these the salient parts of ES2015. There's a few other things, but a lot of them get more about performance or they're just used less frequently. Some of the stuff you should already be pretty good at. Let and const, template literals. A lot of you have gotten pretty solid with destructuring at this point. Default function params, I think some of you have done that as well. Rest and spread, I've seen a few of those also. Fat arrows, man, all these things we've probably done something with. So let's talk about the stuff we're hopefully a little bit familiar with already. Who can tell me what let and const are and why we needed them? Why wasn't var good enough?
var specifically was able to get very easily lost in reassignment. So you could declare it once and then use it again and lose track of what you were actually tracking.
Yeah, that's true. So how do let and const fix that?
Const doesn't let you reassign.
No reassignment. Well, wait a minute then. What is let even? Because if we can reassign that one, doesn't that one get lost in reassignment also?
You cannot declare the same variable name, but you can change what the variable contains.
Correct. But that's reassignment. That's the same thing we had in var.
With var, you could redeclare the same variable, I believe.
Not in strict mode.
Okay, cool.
There's one difference between var and let.
If you try to redeclare let, it gives you a warning of some kind.
It's even simpler than that. It also, another hint, it shares it with const. Const also has this. var is reassignable and function scoped. Let is reassignable and block scoped. This is no reassignment and is also block scoped. So for example, if I have a function, how var works, and I have an if statement, and I say var this will be function scoped. That works. That doesn't. is also true in Ruby and a lot of languages. These curly braces, that's a block. We've got them on functions, we've got them on if statements, we've got them on for loops. Those are all blocks. With const and let, scope is defined by blocks. With var, it was defined by functions. The reason that we didn't just get var and const, the reason we had let, is a bunch of fucking crybabies who came from other languages. Most languages use block scope variables. Like, man, this is confusing. It doesn't make any sense. And so, oh no, if they had to learn something. So let was mostly like to appease those people. There is one thing that let does that I super like, and it's a subtle one. It's like, as you might imagine, this one came in handy. But the more like insidious thing was with for loops. The problem is that still exists outside of that for loop, even though it kind of doesn't look like it should. That was dumb. With that, it doesn't escape the loop. Ask me some questions about that.
Does anybody still use var?
Nope, it's dead. People will throw rocks at you if you put that in your code. In fact, one of my biggest gripes with so my last program, we held on to var for a while, and people were like, we're not even learning the latest version of JavaScript, like it was a big fucking deal. I was like, okay, cool. You know how you've been writing var? Well, write let instead. It's the same shit. There you go. There's your new language. So like a lot of this stuff is not super revolutionary, but this thing in particular, I thought was really nice. And being able to, using const by default, that was something I didn't like for a while, but it's probably like saved my bacon more than it's inconvenienced me. So I like it now. More questions about let and const?
So how do you deal with legacy code that still includes var?
It works exactly like let. It's just function scoped instead of block scoped. That's it. It's the only difference. And so unless you're doing something like this or that, doesn't make any difference. %90 of the time, it'll work exactly the same. And the only exceptions to it are those two things. Switches, I guess, technically also. What else? Onward. Template literals. So once upon a time, people do things like this. Or you'd have to like Sometimes wrap it with spaces. So you do that or that. Awful, absolutely awful. Some people would even use reduce and stuff to get around that. No longer. These work the same way they do in Ruby. Lots of languages have this. Ah, much better. Now, what not everybody realizes is you can do anything you want inside there. You can just put arbitrary JavaScript. So if that's a function and you want to do other shit, you can put whatever JavaScript you want inside of a little interpolation thing. You also don't have to interpolate anything. You can just use backticks all the time if you want to. There's even like style guides and stuff that prefer that. Cool. That's template literals. Questions?
Just since you briefly brought it up, are there any style guides that you think would be particularly useful to us that might have had a VS Code implementation?
Airbnb is a really popular one. I use that one a lot. The Google one is pretty popular also. There's one called Standard that's also fairly popular. I think it was very pretentious and obnoxious of them to name it Standard, but especially since I don't particularly like it. But of the ones out there, like I think Airbnb is probably the most reasonable. Prettier also you might look into. Prettier is it's not a style guide, it's a formatting guide. Prettier is dope though. So it's smaller than a style guide. It's just things like tabs versus spaces and like some of that kind of stuff. Prettier is great though. I'd look into that too. Other questions about template literals? Onward. Destructuring, pretty easy. That's it. If we want to pick a specific thing out of an object and then assign it to a variable, what we're trying to not do is something like const a equals some object dot a. It just replaces that pattern. And yeah, we can take multiple things out of it. Ta-da, that's it. But really, anytime you see a lot of this, that's repetition. And in general, we're trying to get rid of repetition in our code. Destructuring is a way to do that. Questions about destructuring?
So you can do that with any object?
any object. Cool. Default function params. They work the same way they did in Ruby. They just didn't exist in JavaScript until very recently. So we could say some parameter and then equals whatever default value we want. Also works with bad arrows and stuff too. So a word of caution on this one. These are really easy to abuse. You want a default parameter to be a true default, not just something that you happen to do kind of a lot. And so that requires like some semantic understanding of like what the thing you're setting a default to is. But so I'm at a standing desk. And so you could say that my default is standing. I could also be jumping. I could also be sitting down. But like whatever, that's my default position. Now my desk doesn't move up and down. Elisa's desk does. It's got a little crank on it. So that one doesn't have a default. If that makes any sense. Questions about default function parameters?
Could you set the default to like a function?
Yep.
Or is that getting too cute with it?
Nope, you can do anything you want. Any legal JavaScript expression can go there.
Is there something that you've used and enjoyed that follows that idea as just kind of like a structural idea?
No, like you mostly see it in OO code, and I don't write a ton of that. And I think if you have defaults like that, most of the time it points to a bigger problem with like your design. So no, I don't get a ton of action out of them. Let's talk about rest and spread. Rest and spread, the reason they go together is it's the same operator. It's 3 dots. So the difference between them depends on where they're being used. So in your React code, you've probably done something like, we got state equals some list. And then maybe you do set state some list. And then maybe you're doing this dot state dot some list. And you're spreading it. The value of that is it allows us to take whatever is already in there, and it's almost like we typed out what. So if I had like A, B, and C in here, that spreading that is almost exactly like we just took that array and got rid of the curly braces. And so it just became A, B, C. That's all it does, really, is just get rid of those, the square brackets. It also happens to make a copy of those things, which is why like one of the cheapest ways to copy an array is copied array is
So basically that would just be like a shorthand unmodified map.
Yep. But this keeps us from having to do things like pushing, like some of those kinds of things that actually change the original array, which plays real bad in things like React, where we don't want to like handle any of the mutations or changing anything ourselves. We want to let React handle all that. So that's why like you pretty much have to do this. This replaces push. It's the exact same thing as this.state.sumList.push some new thing, except it doesn't actually change some list directly. Spread also works with objects, you may not have realized. So if I have some object like that, I can have some other object spread some object and just add stuff to it. Works the same way. It's kind of like we just dropped the curly braces. Also ends up being a super cheap way to copy an object. Like that. It's a shallow copy, but copy nonetheless.
What do you mean by shallow copy?
Good question. Hoping somebody would ask me that. So, you know by this point that objects are done by reference, not by value. Meaning, object A is that. Object B is this. Cool. So if I did copy of object A like that, these are actually the exact same thing. So if I change object A dot A to 2, the original object A dot A is now also 2. It's not actually a copy of it. It's just a second reference to the exact same thing. So that can get us in trouble. If I do a shallow copy of something and I do something like object A, like that, and I do const copy object B, but it's a real copy this time. I can change copy of object B's B property and object b dot b still equals 1. Those two things are independent from each other because b was a number. Numbers are primitives. So we made a copy of it. But copy of object b dot a still point to the original object A. It didn't make copies of every other reference we have throughout that chain, only the top level. So if I wanted a separate copy of object A, I would have to do a deep clone. The dirtiest way to do that, like I've absolutely done many times, is real deep copy is to json.parse and then json.stringify, or sorry, json.stringify and then json.parse something. Turns everything in that entire tree into a string and then parses that back as an object. The way better answer is to use a library like Lodash and use clone deep. That one's way more efficient. And that's what a shallow copy is. Questions about rest? Oh, so we only talked about spread. That's the one you use most of the time. Rest exists. Functions inside of a function's parameters. So let's say same operator. I do something like that. It actually does the opposite of spread. So you'd use it like, we can put however many arguments we want into that now. And it's going to turn those into an array. Some people have suggested that rest is a shitty word for that. I kind of agree. It's supposed to be like, and the rest of the arguments. The collect operator has been suggested as a better name for it. I kind of like that better too. But then you could do something like numbers dot reduce something like that. Questions about rest and spread? All right, let's talk about fat arrows. Fat arrow, it's just another way to write a function. So we've got this way of doing it. We've got this way of doing it. We've got this way of doing it. like most of the time, that's it. We just got different ways we can write these. There are a couple gotchas between these three versions of functions, though, we should be aware of. One is that this one, let's do it this way. This one hoists. This one doesn't hoist. This one doesn't hoist.
What does hoisting mean?
There we go. That's what I'm looking for. So, does anybody know? I think it's in one of the labs. Know what hoisting is? Hoisting gets made out to be way more complicated than it is. Like, easy answer. That works. That's it. A function declaration hoists, so we can use it before we define it. Oops, did this wrong. A function expression doesn't hoist. So, come on, man. It doesn't hoist, so it throws an error if we try to use it before we've declared it. And it kind of makes sense. Like no other variable declaration or assignment, we can't do that with anything else. I can't do a plus plus let a equal 3. Like that doesn't work. So why would it work if I did it with a function? Makes function declarations a little bit special. There are people that do not like function hoisting. They think it's confusing. And God forbid they learn something. I think function hoisting is awesome. But whatever, I lost that battle. Most of the JavaScript world does not like hoisting functions. So for that reason, they'll prefer function expressions, or way more common now, a fat arrow. So that's hoisting. Questions about that?
Not a question, but that definitely clears up a lot of stuff about like fetch requests and stuff. Because I was just sort of assuming that oh, that's just how JavaScript works, and you get over it and move on with your life.
Yep. There's some hoisting. So fat arrows do one more thing. And I don't want to go too deep on this because it's the single most confusing thing in JavaScript. But it binds the this value. So without going too deep into it, imagine like in Ruby, self can only mean two things, right? It can either refer to the class or the instance. That's it. This in JavaScript kind of works similar, except not really. This in JavaScript is referred to as the context, calling context. And what's confusing about it is it can literally mean 8 different things. That context can change like very easily. And when that happens is functions that have functions inside of them, which have functions inside of them. This value keeps changing inside of each one of these. All of those refer to different things, or will when they're being called, which is also part of the thing that's fucking confusing about it. So with a fat arrow function, this never changes. So here's the practical example of where you probably have seen this in labs. You got some class, and you probably saw at least once. This might have some method on it. And in the constructor, you probably saw something like some method dot bind this. And what sucked is you had to do that for every single method in your class. Stupid. That does the exact same thing. It allows us to do that.
I have a feeling I'll appreciate knowing that in about 5 weeks.
Nice.
Pretty useful in React.
Yes. So we don't have to do this for every method on our class. And when we add and delete methods, we don't have to also delete their bindings in the constructor. Classes in JavaScript are such a nightmare. One more thing that might underscore why this is confusing. Let's say we got some other method and it calls this dot sum method. We've got yet another method and it calls this dot some other method. This seems like this should work like it would in Ruby. The problem is calling context. In yet another method, this refers to the instance. In some other method here, this refers to this function body. Like, shit, no, it wouldn't even be there. God, this is so fucking confusing. And by the time we get to some method, this is way lost. This is referring to the body of this function. Dumb. So we use fat arrows. It only means one thing. In code where you're not using the this keyword, there's no difference between that and that. Questions about fat arrows?
I'm not sure if you went over it, but if you have a fat arrow and then nest declared functions inside of that fat arrow, does this change when you declare the functions, or is it always what this is from the fat arrow?
So another way to think of fat arrows, those two thises will be the same thing, always. Past that, you keep on going down, it follows the same rules as this always does. So if you keep using fat arrows, this is guaranteed to stay the same. You start making those function expressions or function declarations, they follow the rules that those things follow. So if you're looking for general guidelines, using fat arrows pretty much all the time is like not the worst habit to be in. But function declaration, I'll always love you. Other questions about fat arrows?
So if you wanted to try to, is there any way to steal the best of both worlds?
This is it. There's like honestly no like good part of how this used to work. Like despite what Kyle Simpson has argued in some of his books, like, I think it was just a bad idea, and Fat Arrow fixes it. Cool. Let's talk about for loops. So we got 3 different for loops that are worth knowing. Okay, so that's a traditional C for loop. Almost every C-style language has something kind of like that. There's also a for in. Those 2 for loops are the same. What's kind of neat about for in loops they also work on objects. So we could look up values from an object that way. In ES2015, we got for of. Which works like this. This and this are the same thing. We don't have access to the key anymore, but if all we need is the values, we've got for of now.
Would the for of be let value of some object?
Oh, yep. That's exactly what it would be. Other questions?
That first example, do people really use it anymore, or?
So this is what we call an imperative way to do something. We're telling the computer step by step what to do. I would like you to initialize a counter, and so long as that counter is below this number, I would like you to do this thing, and when you're done with it, I would like you to increment your counter. You could also do that, and it works the exact same way. We'd say that this is the declarative way to do it. This is the imperative way to do it. With this, we don't specify how it does the iteration, and frankly, we don't give a shit. We just say that we want an iteration to happen, and we leave it up to the language to figure out how it happens. It probably does something like this under the hood. But we've taken the implementation of something and tucked it away in a word that describes the outcome that we want. Declarative, imperative. So question was, does anybody still do that anymore? Yes. The trade-off that we get with declarative code, yeah, pretty often. And the array applicatives in particular, so map, filter, reduce, find, for each, those are super expensive. This couldn't get cheaper. Actually, it could. If we rewrote that as a while loop instead. So we did while I is less than max. And then we did some array I plus plus. These two things are the same, the for loop and the while loop. The while loop is fast as hell. So if we have some kind of very performance sensitive thing, makes more sense to do this. But fuck, even that I would probably still wrap in my own function. Yeah, anything performance sensitive, that's where you're going to reach for your imperative loops. Otherwise, use the declarative version every time. It's way easier to read. And lets you change the implementation without actually changing the thing that you want to happen. Other questions?
Is the for of only with objects?
Yep. Wouldn't make no sense with arrays. All right, speed round on the other two. Promises or just anything you can dot then. Sometimes promises are also called thenables. They automatically always return promises themselves. So you can make these then chains. If anything throws an error, you can catch the error. You can catch more than once. So if this first one throws an error, that first catch block will get it. Otherwise, it just moves on to these two. And if either of them throw an error, that catch will handle it. Some things that you do already. Fetch. Fetch evaluates to a promise, so we can dot then it. If you do any node code, and you like read a file, that's also asynchronous, and you'll need to handle that. You can also like, you can write your own promises. I find that sometimes something doesn't start with a promise, but uses a promise somewhere in the chain, and like, I really wish the entire thing would just be a then chain. So that evaluates to a promise that doesn't return anything. And you can just start .thenning it. You can also make your own promises. Promise takes in a function. The function will be given resolve and reject, which are also both functions. And if something goes right, that's promises.
So if you were doing that where you like made a promise chain before you actually needed it, is it in the .then that you would call like the first function that you wanted?
Sure.
Or resolve?
You can do it either way, actually. Okay. So like, if you do that, it's going to be available as whatever the argument is.
Okay.
And then that'll be like that. It automatically promisifies like anything that you return out of that. Then lastly, classes. Classes don't actually exist in JavaScript. This is what's referred to as syntax sugar. What's happening under the hood is a completely different thing, which is one of the reasons that classes are so broken. But you can do something like that. You can assign properties. You can make methods. You can also kind of mix and match those and do some function expression like that. And then inside of that, you can do things like this dot some property or this dot some method. There's a magical thing called a constructor. That's what's going to get called when you call new, just like in Ruby. And then there's also the super keyword, which super is the constructor for some other class. And maybe I give it the same parameters or nothing or whatever I want. However, some other class's constructor is supposed to work. And that's classes. And that's ES2015. What else?
I mean, I guess I guess often enough because they implemented it, but like how often do you use classes in JavaScript?
Increasingly less. I think it was a mistake to put it in the language, and I think a lot of, unlike everything else, where I'm the harbinger, that's one that I think most people have kind of agreed with me on over time on. So they're coming out of React. We're doing hooks instead, so everything will be a functional component. They'll never come out of the language at this point, but the only place where I actively use classes in JavaScript is for models. So if I'm writing a backend, I still use classes for models, and I think they work pretty well for that. But everything else, they're just a bad idea. Or they're a fine idea that didn't really get implemented very well. But one of the things that's powerful about JavaScript, and one of the reasons it's as widely used as it is everybody thinks it's their language. The OOP people think that JavaScript's their language. The functional people think it's their language. And TC39, the JavaScript committee, does like just enough to keep all of them happy. And so it ends up being a maximum flexible language. Oh, I'll also say, and this might like bring classes back kind of, classes are actually fucking great in TypeScript. TypeScript fixes every gripe I have with classes. Cool. I'm going to send out a survey. Thanks for hanging out with me and talking some ES2015.
Thanks for doing this, Kyle. That was really great.
Yeah.
Awesome. I'm glad.
Awesome. Thank you.
Cheers.